Hello students. So in this video we will continue the topic. In this video we will study the power set, the definition of the power set, the total number of the elements of the power set, and after that we will study the universal set. Okay. So what is power set? A power set is nothing but the collection of all the subsets of some set A. That is, collection of all the subsets of some set A is called as the power set. That is, the definition for the power set is the collection of all the subsets of some set A. The collection of all the subsets of the some set A is called power set. Is called the power set. The power set is denoted by the letter P of the set A, power set. And the if a set contains m number of elements, then the total number of elements of the power set P of A is 2 to the power m. That is, if a set A contains m elements, then the total number of the elements of the power set P of A is nothing but 2 to the power m. That is, for example, I would like to give the example of the power set. The power set P of A, which contains the elements, the null set, the element PB, like a set 1, that set 2, like the set 1, 2. You can note here that each element of the power set, is a set. You can note on this, each element of the power set is a set. Right? You can observe here that each element of this power set is nothing but a set itself. Therefore, the collection of all the subsets of some set A is called the power set P of A, and the power set is denoted by P of A, the letter P of A, and if the number of elements in the set A is m, then the total number of the elements of the power set P of A is 2 to the power m. Okay students, the next one is the universal set. As we know that universal set, the word universe itself is the biggest set. Okay, so basically the universal set is the biggest set which contains all the sets. Okay, so a universal set, a set which contains all other sets. A set which contains all other sets is called universal set. Is called the universal set. And the universal set is denoted by the letter capital U. Okay, so U stands for universal set, which basically contains all the sets available. So the collection of all the sets is called as the universal set. Okay students, so based on these definitions, let us start solving the problems in the given exercise 1.3. Okay, so let's start the problem solving of exercise 1.3. The first question is, Make the correct statement by filling the symbols subset or not subset. You know that this symbol stands for subset, this symbol stands for not subset. Already we discussed in the last video, right? So subset or not subset, you will fill in the given proper blank space in the blank spaces. The first one, look at the first set. The first set contains 2, 3, 4, and the second set contains 1, 2, 3, 4, 5. We have to use one of the symbol, either it is a subset or either not subset. Right? I just want to recall, subset means if all the elements of the set A belongs to the subset B, then A is a subset of B. Already we know this definition. So with respect to the same, there are two sets given here. One set contains 2, 3, 4, another set contains 1, 2, 3, 4, 5. So please you can observe here that by each element you have to observe that each element of the set, this set is either belongs to this set or not. Check it out. 2, 3, 4. 2, 3, 4. Yes, each element of this set belongs to the second set. It means this set is a subset of the second set. The first set is subset of the second set. Come to the second example. The second example contains the set A, B, C and a proper space for using these symbols, and the second set is B, C, D. The second set is B, C, D. It means you have to check the elements of this set is either belongs to this set or not. This set or not. Okay, you have to check. So the A, B, C. A is not belongs to this set. B belongs to the set, C belongs to the set. It means that fails the definition. The definition fails here that each element of this set must be an element of some another set. It means clearly this is not a subset. Each element of this set must be the element of the second set. Right? Fine. Come to the third one. These two sets in the third example given in the set builder form, right? So first set is the set of all x such that x is a circle in the plane. X is a circle in the plane. Okay, it means there is a plane, and there is a x called circle. So the one more set given is, so x set of all x such that x is a circle in the same plane. In this same plane, another x is another circle in the same plane with radius 1 unit. With radius means the distance between the circumference and the center is called radius. With the radius 1 unit, it means which one symbol is fitting here? Either these two sets or one of the set is subset to each other or not? Definitely no, because this circle has no proper idea of the radius. This circle has a radius 1 unit. It means definitely this circle is not comes under the second circle with the radius 1 unit. Therefore, the symbol source is not belongs to, that is not subset. Coming to this seventh example. The set of all x says that x is an even natural number. X is an even natural number. We know that 2, 4, 6, 8, 10 and so on, all are even natural numbers. It means we have a clear idea about even natural numbers. Now one more set is given is set of all x says that x is an integer. What are integers? There are some negative integers, there are some positive integers. It means there are some negative numbers, there are some positive numbers are available. It means these are the even natural numbers lies in the positive side of the integer. Therefore, definitely this is the subset of the second set. Definitely the even natural numbers like 2, 4, 6, 8, 10 are present in this set. Okay, they are present in the integer set. Therefore, definitely the symbol source here is the subset. Okay students, the next example is examine whether the following statements are true or false. We have to check whether they are true or false. We have to check whether they are true or false, right? Okay. So given that a set which contains A comma B, the set AB is not a subset of B, the set BCA. Yes, whether it is true or false. Any idea about this? What he is telling is that the set which contains A comma B is not a subset of the set which contains BCA. It means definitely yes, false. Because if you find the subsets of this set BCA, what you are going to get? You are going to get the singleton elements. After that, the double elements. After that, 3 elements. After that, null set. So these all are the subsets of the given set BCA. Now check whether this element is present in this group or not. Yes, definitely the A comma B is a subset of the set BCA. It means what he has given is false. What he has given is false. Okay, so what is your answer? Your answer is false. Your answer is false. Next, the set which contains A and E is a subset of the set which contains X is an vowel in the English alphabet. What are the vowels? What are the vowels? A, E, I, O and U. So these are the 5 vowels in the English alphabet. Now check whether these 2 elements are present here or not. Okay. So A comma E is a subset of this set. Definitely A and E are the elements of this set. It means the second statement is true. The answer for this is the second statement is true. The second statement is true. Next, the set which contains 1, 2 and 3. The set which contains 1, 2 and 3 is a subset of the set containing 1, 3 and 5. Is it possible? No. Because the element 1, 2, out of the elements 1, 2, 3, the element 2 is not the element of the second set. It means the given statement is definitely it is a false. Definitely it is a false. Coming to this one, can you please think on this? The set which contains A is a subset of the set A comma B comma C. A comma B comma C. Think. Just now only I wrote all the subsets of A, B, C. Out of that, the set which contains only one element A is subset of the given set A, B, C. Therefore, this statement is true. This statement is true. Let's go to the fifth example. The fifth example is a beautiful example. Okay, you can think here that what he is telling that the set which containing A is belongs to, not the subset, belongs to the set A comma B comma C. There is a big difference between the subset and the belongs to. Right? I already told you. I write once again. What are the difference between the subset and the belongs to symbol? For the subset, both the sides of this symbol, both the sides of this symbol must be sets. It means one set is a subset of another set. It means both the elements or both the involvement has been done by the sets. It means both must be sets. The one which is a subset and one which has a subset, both must be a sets. But in case of the belongs to, the elements must be belongs to the sets. The elements must be belongs to sets. It means the difference between these two is that if there is a symbol like subset, then both sides of the symbol there must be a set. But in case of belongs to, the elements are only used by the belongs to. It means so the set A is not an element of the A, B, C. You can observe the set A is not present in this set as an element. Therefore, the statement is false. The statement is false. Hope you recorded, you understood all the concepts. the difference between the fourth and this fifth example is, this is a set A which contains, which is nothing but a set itself, which is a subset of this set, no doubt. But the set A, if the symbol belongs to comes, then it must be, what is the right answer for this? What is the right answer? If the symbol is belongs to, if the symbol is belongs to, then the set A must be belongs to the set which contains like this. You can see. If this is the case, then I can say that the set A belongs to this set, because you can observe the same set is present here. You can see the same set is present here as an element. Note on this. Okay students, so one more example is given. If set A equals to 1, 2, comma, the set which contains 3, 4, comma, 5, then which of the following statements are incorrect and why? Okay, if the set contains 1, 2 element, along with the element which is a set itself, the set contains the elements 1, 2 and 5, which also contains the element which is a set 3, 4. Now we have to find which one of the given statement is incorrect, and we have to tell what is the reason that it is incorrect. Right? Okay. Look at the first one. The set containing 3, 4 is a subset of A. Right? As the set 3, 4 is the element of the A, definitely this is incorrect. Definitely the first is incorrect, because write the reason that the set 3, 4 is an element of the given set A. Is the element of the given set A. This is nothing but the element. This set 3, 4 is nothing but the element of the given set A. Therefore, if this is an element, then that should not be a subset. Right? Okay. The elements are written in the set. Then only the set belongs to some other set, which is subset. Second one, the set containing 3, 4 belongs to A. As just I said, definitely the set which contains 3, 4 is the element of the A. Then this is correct. Then if it is correct, then there should not be any reasons. Come to the third one. The set which contains the set 3, 4 is definitely, I just told you in the first example, if the same thing is written in the set, then the symbol subset is worked here. Now the same reason is elaborated here. The set which contains the element in the set 3, 4, then this is correct. Coming to the fourth one. The element 1 belongs to A. You can see clearly 1 is the element of the A. So 1 belongs to A, 1 is the element of A. 1 belongs to A, 1 is the element of A. Then this is correct. 1 is a subset of A. I told you 1 is a subset of A. I just told you that if the symbol subset used, definitely the both sets must be a set. Then 1 is not written as a set. Therefore, this is incorrect. Because write the reason that the 1 is element of the set A, not a subset. 1 is element of the set A, not a subset. Therefore, 1 is not a subset of A, or one subset of A is an incorrect statement. Hope you can do the next one. Okay, you can take your own time. You can see the set which contains 1, 2, 5 is a subset of A. Definitely, it is a subset of A. True it is. It is true. It is correct. Because you can observe that the elements 1, 2 and 5 taken together as in 3 elements and written as a set. Definitely this set is a subset of the A. Seventh one. The set 1, 2, 5. The set 1, 2, 5 belongs to the set A. you can observe here that before the belongs to what has been written as a set, you can observe that completely this is an element of the set or not? No, definitely not, because this contains only the set 3, 4 but not the 1, 2, 5, and this is the incorrect statement. This is an incorrect statement. Reason is that the set 1 to 5 is not an element. The set 1 to 5 is a subset of the A. Is a subset of the A. Eighth one. The set containing 1, 2, 3 is a subset of A. Is a subset of A. You can observe whether the 1, 2 belongs to the set A or not. Yes, they belong to. But 3 is also belongs to the set A, but it is written in the set itself. Therefore, this is nothing incorrect statement. Because you have to write the reason that the 3 is not an independent element. 3 is written inside the set, in the set A. Therefore, this 1, 2, 3, the set containing 1, 2, 3 is definitely not a subset of the set A. Coming to the ninth one, 5 belongs to A. You can check. Is there any element like 5? Is there any set like 5? It means this is not belongs to the set A, because 5 is always a subset of A. 5 is always a subset of any non-empty set. The 5 is a subset of any set. Therefore, this is not the correct statement, incorrect statement. The reason is 5 is not belongs to A, as 5 is not an element of the A. Is not an element of the A. Coming to the 10th one, 5 is a subset of A. Yes, as I just told you, 5 is definitely a subset of A. 5 is a subset of A because 5 is a subset of any set. 5 is a subset of any set. Come to the 11th one, then this is the correct answer. Coming to the last one, the set which contains 5. The set which contains 5 is a subset of A. Definitely true. Correct. Right? Definitely the 5 is always a subset of A. The set which contains 5 is a subset of A. So note down this. Okay students, so one more example. Next example is write down all the subsets of the following sets. Okay, we are very much clear about writing the elements, writing the subsets, right? Already we have said in the definition. So the subsets of the sum set can be written. The subsets of the sum set can be written choosing one element in the set at the for all the elements, choosing 2 elements for all the pair of elements, choosing 3 elements for all the triple pair of the elements, and so on up to the n number of pair of elements, including the 5. Including the 5. It means including the 5, the singleton elements, double elements, triple elements. So different type of the elements are there as in subsets. So let's find the subsets. So for the given set A, the subsets are, okay, the first subset. So to write the subsets of A, okay, to write the subsets of A, it is compulsory that you have to write let A equals to the set A. If you are not taking the given set as the A equals to or some set, B equals to or some set, C equals to, then you won't get the marks, because you know that the sets are always represented using the capital letters. Therefore, the let A equals to A, and you know that the subsets of the A are A1, A2, A3, A4, A5, and so on. Right? Okay. So the subsets are the first subset is the element A. The second subset is 5, because there are no more elements in the given set A. Therefore, we have chosen the element A, and there are no more elements. The 5 is a subset of A. Come back to the second example. Let the set A equals to A comma B, A comma B. Then the subsets are A1, A2 and so on. We'll write it. So the A1 which contains one element A2 which contains one element of the set A, and the A3 which contains both the elements of the set A, and at the last A4 the phi, because we know that phi is a subset of every set. Phi is a subset of every set. Okay. So I repeat again. If a set let A equals to A comma B, choose single elements once and double elements once and so on. So the element which is A, so A1 is the set A, A2 is the set B, A3 is the set which contains both elements A, B, and the A4 is the null set phi, Come back to the third example. The third example is the set containing 1, 2, 3. The solution is that A equals to 1, 2 and 3, and the subsets are A1 which contains 1, A2 2, A3 3. After this A4 which contains double elements like 1, 2, A5 1, 3, A6 2, 3. The maximum pairs are here. Out of these two, we have to choose 2, 1 and 2, 1 and 3, and 2 and 3. You can see, is there any possibility of choosing any two non-repeated elements? See, 1, 2, 1, 3, 2, 3, all are non-repeated pair of elements. Okay, so single elements, after that double elements, after that triple elements. So after A6, the next subset is A7. After the single elements, double elements, the next one is 3 elements. The 3 elements taken together all are the set A7 equals to 1, 2, 3, and no doubt the last set is phi, because by default, by definition, the phi is a subset of every set. Right? So we can go for the next one. The next one is, the fourth one is the phi. The phi. So as we know that the phi contains no elements, therefore we have to write it like this. Let A equals to phi, therefore the subset A1 is the phi itself. Therefore the subset A1 is the phi itself. Okay, note on this. Okay students, the next one is, the fifth question is, how many elements that P of A has, how many elements the P of A contains if the set A is a null set. If the set A is a null set. Okay, so let us solve this. So what is given? What is given to us? Given to us is, let A equals to null set. A equals to null set. It means number of elements in the set A is 0. There are no elements present in the given set because the set is empty. Phi is empty set. Therefore, total number of elements of the power set P of A is 2 to the power m. Is 2 to the power m. Now what is the m value? M value is 0 because m is number of elements in the set A. M value is 0. Substitute over here 2 power 0. We know that any number whose power is 0 is always 1. Any number whose power is 0 is always 1. It means if A is a null set, then the collection of all the subsets, power set is nothing but collection of all the subsets. The total number of the elements in the power set P of A is 1. I can say like this. N of P of A is 1. N of P of A is 1. Note down this one. Okay students, the sixth question will be, write the following as an intervals. Okay, So using the definitions, we are very much capable to convert the set builder form into the intervals and intervals into set builder form, right? Okay, so here one of the examples are given, 4 examples are given, and asking to write into the interval form of the given set builder form of the value, right? Okay, the first one, the set of all x, such that x is a real number and 4 is less than x is minus 4 is less than x is less than or equals to 6. That is, x belongs to minus 4 and 6. We have to use the interval here. There are two types of the intervals. One is open interval like this, and one is closed interval. Like this. Okay. So what is the meaning of open interval? If set x belongs to, I write the definition again. If set x belongs to open interval a comma b, then x can take any value. X can take any value between a and b. X can take any value between a and b except a and b. It means x may be a plus 1, a plus 2 and so on, but not x. Except these elements, x can hold any value between a and b except a and b. This is the definition of value, meaning of the open interval. As soon as if x belongs to closed interval a comma b, then x must be equals to a and rest of the elements including the a. It means if x belongs to closed interval a comma b, x equals to a plus 1, a plus 2 up to b minus 1 and b, including the a and b, x can hold any value. Therefore, this is the definition already we learned. So using the same concept, we have to solve these problems. Okay, we have to solve these problems. Now look at this. As less than indicates, I write once again. I told you once again that the symbol less than is same as the open interval. The symbol more than is same as the closed interval. The symbol less than or equals to is same as the closed interval open, and the symbol more than or equals to is same as the closed interval. Okay. Here you have to remember these. Now, as x is excluded by the 4, open interval, less than or equals to slack inequality, closed interval 4, closed interval 6. That is, x belongs to open interval minus 4, comma closed interval 6. Look at the second solution. Here, as x is a real number, minus 12 is less than x is less than 12. It means both are strict inequalities. It means both are open intervals. X belongs to open interval minus 12 and 10 because both are strict inequalities. I just told you, if strict inequalities comes, then open interval, then slack inequality comes, then closed interval. Right? Then closed interval. Fine. Okay. So according to that, minus 12 is less than x, open interval, less than strict inequality, less than 10, open interval. Come to third example. So solution is, as x is a real number, 0 is less than or equals to x, slack inequality. It means x belongs to closed interval 0, open interval 7, open interval 7. The fourth one is x belongs to 3 is less than or equals to closed interval 3, closed interval 4, closed interval 4. Okay. So note down these. Okay, students. Now the next question, the seventh question is, write the following intervals in the set builder form. Okay. In the last column, we have wrote the set builder form into interval form. In this question, we have to write the set builder form for the given interval form, right? Okay. So as minus 3 comma 0. So what we have to write? If x belongs to open interval minus 3 comma 0, then okay, what is the interval form? The interval form of this is the set of all x has that x is a real number, right, and minus 3 as the open intervals are appear, strict inequality, x 0 also open interval, strict inequality 0, as both are open interval, both are strict inequalities, right. Second one, if solution, if x belongs to open interval 6 comma close interval 12, then there exists a set of all x's that x is a real number, and as open interval the 6 has strict inequality, x as this is close interval, it is slack inequality. You can see close interval leads to slack inequality, open interval leads to strict inequality, right. So x belongs to R such that 6 is less than x is less than or equals to 12. Now similarly we have to write down the third and fourth. The third one is you can see that as both are close intervals, the slack inequality will come. The slack inequality will come. Look at the last one. If x belongs to close interval minus 23 comma 5, then the set of all x's that x is a real number, and as this is close interval, minus 23 is less than or equals to x. As this 5 has an open interval, less than 5 is your answer. Note on this. Okay students, there are 2 more examples given in the book. Please you can solve them. Okay, you can solve them. And in the next class, in the next video, we will study the Venn diagrams. We will study the Venn diagrams. How to represent the sets into the Venn diagrams. There are some operations on the Venn diagrams. There are some formulas. There are some techniques to solve the problems using the Venn diagrams. Okay, using the Venn diagram, we can explain, we can show the empty set. Using the Venn diagrams, the Venn diagrams are helpful for representation of the sets. The empty set can be represented through the Venn diagrams. The subtraction of both the sets, universal sets, power sets, all type of the sets will be represented using the Venn diagrams, and there are some more problems on the Venn diagrams we will study in the next video. Thank you.